What? Okay, this is the MicroLogix 1200. Right now, we're going to be peeking around. We're going to open it up. We're going to find more of the important chips inside, and we're going to speak on what those are. Right now, I'm about to be plugging up the device to show that it works. Okay. Now we can see that we have power and run is on. So this is a functioning device and we won't be surprised when we break it open. First off, we're going to break off this memory chip. We're going to put it under the microscope and go ahead and get that out of the way to show you what we're going to be doing in the future with this device. First off, we put it under the microscope and we get these two memory chips. And we show the back transistor, and this is the sheet that we're going to be doing on all these boards in the future. This is what we're working with. Okay, now as you can see, we have these screws. We're going to be unscrewing these rails. We're going to be unscrewing the bottom so we can disassemble the device. This right here is the out rail. What I'm unscrewing right now is the input rail. Now that we broke this open, here's what we're introduced to. And here's a close-up. These are the chips that we're going to be getting the codes on and looking at, the front and the back. This is the middle board. We're going to be getting some chips off of there. And then we have the bottom board. And that's what we'll work with. For now, we're gonna get a close-up and sweep over the board so you can get a better look. Now we're gonna start with the top board and then we'll move on. ADM202EA is a robust 2-channel interface device said to be suitable in harsh electrical environments, i.e. outside. I didn't really find too much on the data sheet, but that is what it told me. Okay, next up we got a 16.00p. I am not very sure. The only thing that I am sure about is it's an oscillator that likely runs at 16 megahertz. Okay, A181 and A561, they're resistors. I couldn't be bothered to remove them from the video, so they were just interesting looking multi input output resistors. HA14 on the datasheet on this one says it is well, this one's pretty interesting because it's basically a 3 input and output transistor that runs at 3 voltage ratings. It has a 3 volt, a 4.5, and a 5.5 volt rating, and it has A6 through Y6 on inputs. It has your power in, and it has a ground. F1110 is just a transistor. I couldn't find any data sheet, and it wasn't really worth my time even looking for it. FPX 22.1. It is it's another oscillator, and it runs at 22.1 megahertz. Go figure. ADM 1485 ARZ, which is what I looked up. I found the data sheet on it, and it pretty much says that it's a transistor that's capable of NXP's Wi-Fi and Bluetooth. It's pretty much a low power 5 volt, and it's able transferring data at 30 megabytes. Not too shabby, to be honest. Now we have CUI 62256LL-70, and these two are the same, and the datasheet says that it is a 32 kilobyte CMOS static RAM. So it's pretty much just RAM stick. Well, I think there's 2 of them. So PXAG30. The datasheet on this one says it's a 44 pin. Well, I know it's a 44 pin, and it is a 16-bit microcontroller. It would be a pain for me to read any more into it. So here's the block diagram for that. Moving on, we now have the second board. 305AG. I didn't really find a datasheet for it, but I'm pretty sure that this is for noise reduction, or whether this is a noise filter. TLP 620-4, and the datasheet tells me that it is a photo transistor optically coupled to 2 gallium arsenide infrared emitting diodes connected in inverse parallel. What? Okay, 537-608. Not really sure. I think it's just another filter. This JA7, it's just a diode. Lastly, the power board, and the most disappointing. UC2845D. The sheet says that this is a fixed frequency current mode controller. CNY 17F-2 is an optocoupler consisting of a gallium arsenide infrared emitting diode optically coupled to a silicon planar phototransistor detector used for signal transmission in between electrically separate circuits. So that's the end of the video. And like I said previously, we're going to be breaking the circuit down and trying to see if I can like desolder everything on the board, follow all the traces, and be able to recreate it in something like KiCad, so I could just upload it. I would look and see if I can find any parts for it, but I'm probably not going to be doing that or going that far. I just want to break down the circuit completely. I want to see the whole circuit on a blueprint. That's going to be a future video thing. It's not going to be a right now, so maybe in a couple of videos I'm going to put together a circuit. One of the circuits I showed after we looked at the memory chips, or yeah, the memory chip, that is the full package. That's all the components on it, but it's not, all the traces on the board haven't been routed yet, so we're going to do that later.